My name is Sean Kinney. I'm the managing editor for RCR Wireless News and Enterprise IoT Insights. With our partner Qualcomm Technologies, I'd like to welcome you to today's webinar titled New 3GPP Effort on NR in Unlicensed Spectrum Expands 5G to New Areas. Some quick programming notes. This webinar initially covered the topic I just mentioned as well as private IoT networks. But in order to cover each topic in more detail, we're going to address private IoT networks in depth during a second webinar scheduled for May 31st. And there will be more information forthcoming about registration for that. Also, please note that we've set aside time at the end of the presentation today for Q&A, so I'd encourage you to submit questions through the webinar portal, and we'll take those at the end of the presentation. Today for Qualcomm Technologies, welcome Juan Montoco, Senior Director of Engineering. Juan joined Qualcomm in 1997 and has worked in system design and standardization for systems including satellite, 3G, 4G, 5G, and Wi-Fi. He led the Qualcomm Research Group Germany from November 2011 to July 2015, working on gigabit cable modem design and standards, as well as Wi-Fi modem design and implementation. Currently based in San Diego, Juan led the system design of NR unlicensed and spectrum sharing, and has recently moved back to the 3GPP team. We'll hear more from Juan momentarily. As we all know, the telecom industry is eager to deliver commercial 5G services ranging from immersive VR and AR to remote industrial control, all supported by ultra-high capacity, incredibly low latency networks. But before these new services can be made commercially available, 5G technologies have to be standardized. That's where 3GPP comes in. The group works with member companies to study and create global standards for telecom networks. While the group's work covers everything from codecs, security, and quality of service, the three major technical areas of study are the radio access network, the core transport network, and service capabilities. The next spec from 3GPP will be Release 14, which includes features like LTE support for V2X, enhanced LAA, and 4-band carrier aggregation. At the same time, work related to Release 15, which includes technical specs for 5G New Radio or 5G NR, is ongoing. Following Mobile World Congress, 3GPP members convened a plenary in Dubrovnik, Croatia, the outcome which has big implications for 5G. Qualcomm and other industry leaders pushed for an accelerated timeline that contemplates a non-standalone 5G NR variant as soon as early 2019. Non-standalone 5G NR will use the LTE radio and core network as an anchor for a new 5G carrier, which will set the stage for early deployments. And while the accelerated schedule got lots of attention, there's another very important outcome of the meeting in Croatia. 3GPP members also agreed on a study item, which is the first step in the standardization process, which focuses on 5G NR operating in unlicensed spectrum. The study item considers both standalone unlicensed deployment as well as license-assisted deployment. So to learn more about this development, I'd like to turn it over to Qualcomm Senior Director of Engineering, Juan Montoco, to take us through a more detailed discussion of 5G and unlicensed spectrum.
Thank you very much, Sean, for the nice introduction, and welcome all to the today's webinar. Well, 5G starts with actually what is it? What is our vision about it? And it might be difficult to define in few words what 5G is, but actually probably the most the pillar definition of it would be unifying connectivity fabric. It does actually put together a lot of use cases, a lot of scenarios with a particular common underlying system, a shared network, and actually a physical layer, fine design that scales for different use cases. We do believe there are three basic major pillars for deployment scenarios. I mean, first of all, enhanced mobile broadband. This is taking the data connectivity to a new level. Secondly, we have mission critical services. This is taking latency critical communications as well as extreme reliability applications like robotics or medical type communications. And then massive Internet of Things, where we are expecting a very high density of devices connecting with potentially low data rates with networks. As we see, these are very, very different, diverse type of applications, but 5G basically encompass all of them. We do believe that there is actually another opportunity that 5G brings about, which is a very embracing use of the spectrum, as we will see in the sequel of the presentation. 5G will indeed redefine a wide range of industries. When actually 4G started, and actually the very first workshop for 4G was in 2004, it was prior to the smartphone era, and actually was difficult at that time to realize or to predict what LTE, what type of services LTE was going to be used for. And we are in a similar situation today with 5G, where we are at the crossroads of actually, we know where we can go with LTE and with its own evolution. And we know that we want to go to the next level for the next decade when it comes to wireless connectivity. Some use cases that already are in mind are in these very high data rate demanding applications, such as, basically virtual reality, immersive entertainment, and augmented reality. Also, self-driving cars with autonomous transportation, and basically sensor exchange between vehicles. Also, reliable access to remote healthcare and actually medical applications, as well as public safety and security that probably will not rely on cell towers, particularly for carrying on connectivity, or basically providing a connectivity. There is also emerging areas such as private IoT networks, which it's emerging at this point in time. We do know industrial IoT is a very important area, and we do have a lot of actually connectivity requirements in that area, and most of those are carried out today with wireline communications. So it does also bring about some very interesting opportunities. From day one, also, we want to create a system that is efficient, energy efficient, and actually that propagates all the way to the waveform and physical layer transmissions, where now the signals are transmitted to a bare minimum of basically necessity. It basically allows cells to be discovered, but also allowing them to go in periods of sleep or no transmission, where actually energy gets saved. Autonomous manufacturing, sustainable cities and infrastructure, as well as digitized logistics and retail are other particular, types of industries which could benefit or will certainly benefit from 5G. So if now we look, and in the introduction, Sean already alluded to, in the March plenary meeting, 3GPP plenary meeting, we did have actually a very important decision. We are at this point in this blue dot, and actually that means we just started in March, or after March, the work item for release 15. That is the start of the basically specification normative work for NR, the very first version of NR. NR is going to evolve over a number of releases in the same way that LTE started with release 8 in 2008. And actually, at the same time, there were, and basically, by the way, this will go all the way until mid of next year. June 2018 will be the closure of release 15 NR, but it was agreed to have an early and basically completion of the non-standalone mode of operation, the one that is the mode of operation that relies on an LTE anchor, basically, that actually governs most of the control plane communication and for example, mobility management, and then uses NR as a data pipe. Particularly, this at the very high level, this is what the NSA or non-standalone is about. I mean, basically using NR as a data pipe, using LTE as basically control plane and coverage blanket, also for mobility management. So that will be completed in December at the end of this year. And it came about because of appetite from many companies, many operators, vendors around the globe, Qualcomm being one of those, in actually a perceived actual, as I said, appetite on having deployments, early NR deployments as early as 2019. So we were going with a regular time frame of completion of June next year. That was going to make it very difficult to get these early deployments in 2019. Effectively, this acceleration allows us to provide those. And certainly there will be these standalone mode of deployments coming later. Then things will continue. We just effectively released recently Qualcomm, this gigabit LTE grade modems. We also have now the very first deployments, commercial deployments of eMTC and BIoT coming up worldwide. And LTE will evolve in parallel to NR, providing actually access to some new verticals. And actually those new verticals will be served probably for some time by LTE and NR. Just to give a very quick one, for example, a study that was approved is LTE for drones, which also just shows the importance of actually these new verticals into 3GPP. Now moving on into the scope of NR unlicensed. NR unlicensed was one of the study items that was open. Not many were open actually. It was approved. The work will not start until after the June plenary. So this is at the working group level sometime in August in the physical layer group, which is the main group defining the specifications of the waveform and so on. And there are, I mean, the scope is actually very broad. Is indeed showing the growing interest of actually the entire industry into accessing this type of spectrum. It's unlicensed spectrum. We'll talk a bit more about the types of spectrum in a second, but the scope includes a NR-based LAA. LAA is this license assisted access, is in a way using an LTE license anchor. That license anchor, when NR standalone gets specified, also would be able to be NR-based itself. But actually, the unlicensed is always anchored to a licensed carrier, which actually also will carry out all this mobility management, for example, and some of the critical control information. There is also, for the first time, a standalone unlicensed component. This had never really been approved in 3GPP, and this is really the main purpose of this webinar. 3GPP is a community of companies. I mean, actually, it's grown tremendously over the last decades. And actually, there are many interests, there are many companies, there are vendors, there are operators, but a standalone unlicensed is not basically to the first sight coming across as a traditional way of actually what 3GPP would actually be working on. That is probably one of the reasons, without getting into the details, why the Multifier Alliance was created actually. But effectively, now it's in the scope, NR operating a standalone in unlicensed spectrum without any necessity for a license anchor. And in some sense, this is what we are now calling, is becoming the multifier evolution path towards 5G. We will see that actually from the physical layer, from the lower layer perspective, the design of NR fits very, very well into a license operation. And I hope with this webinar, you will get a better sense of why is this the case. And then a couple of other aspects worth mentioning are service continuity. When we are moving, for example, from even for traditional operators, they are even thinking about, I want to deploy, for example, to extend my data offering pipe, or my size of the pipe for data in this particular hotspot region. So there will be regions where, or there will be occasions where we would need to have service continuity defined between licensed and unlicensed bands. Also remember, in some parts of the world, I mean, US being one of them, definitely, sometimes the frequency options are regional, and some operators might not have a blanket nationwide coverage. So basically, having access to unlicensed operation could extend the reach of their offering, the coverage offering, making it very attractive to even existing incumbent operators, but without frequency assets, licensed frequency assets within a particular regional area. And then lastly, it does cover all types of spectrum, from the low bands to basically millimeter wave. Even within millimeter wave, NR, when being defined, I mean, actually, the work item, the start of the work item coincides with the ending of the study item for NR as a whole. And actually, that for one reason or the other, there was a limit that was set on the spectrum to basically of interest, being set forth as 52.6 gigahertz. So there is actually a quote on the NR work item that also got approved in the same March plenary meeting, that basically all normative work that we are going to be doing for the rest of the year until mid of next year is going to be considering only spectrum up to 52.6 gigahertz. Well, interestingly, for the unlicensed study, we are lifting that requirement and basically going beyond those 52.6 and covering a 60 gigahertz band, which are actually very important. We know those are existing bands. There are actually bands at that level, even in the 70 gigahertz range in the US, that have been recently identified for communications. And actually, with the caveat that we will not, the study is just meant for effectively unlicensed, if you wish, connectivity. We don't want to change necessarily the waveform. So the waveform changes. There is some appetite to maybe revisit what type of waveform. This is OFDM versus single carrier type waveform is more suitable for this type of frequency regimes. That would be outside of the scope because it's nothing to do with the unlicensed access per se. But other than that, everything else, it's actually within scope. And actually, we were very happy to see this included. So just to recap, the scope is very large. It's a study. The study will last until June next year. This is also when release 15 will complete. It's a release 15 study. And after that, we are hoping to open a work item with a scope basically along the lines of this study. What is going to be the final scope still is TBD. It's not up to Qualcomm alone, but we are working with all our partners to make it as broad as possible. So to get here was not easy, and actually it took us many years to get where we are and to see where we are today. So there are many years, as the title says, in the making to lead up to where we are with NR and unlicensed. And if you look back, the work started roughly about 5 years ago when we first envisioned LTE, putting LTE, placing LTE in unlicensed bands. I mean, and actually that started with 5 gigahertz being the prime goal or the prime target band. And if you look at it, LTU and LAA at the concept level within the research groups in Qualcomm started basically at the same time. And that led to basically different paths. I mean, one towards this LTU forum, and another one to the opening of LAA study item in 3GPP, followed by the work item and actually even its own evolutions. As we know, we've gone from a release 13 LAA to a release 14 with downlink only, to release 14 ELAA with adding uplink for unlicensed. And now there is a release 15 FE LAA, further enhanced LAA, that actually enables other enhancements, particularly to try to limit or reduce the latency. So we are now, it's somewhat a limited scope, but actually we're enabling transmissions, multiple ending, started and ending times for transmissions beyond the current supported ones, which is basically 1 or 2. Also, autonomous uplink transmissions is part of the scope, which is also something that, for example, from Multifier we learn would be very useful to add. I mean, a little bit later, and I think probably based on this initial reaction of 3GPP community, a Multifier was created. Basically, that basically put or gave birth to the concept of putting cellular standalone on unlicensed. And this is why, I mean, we could debate the name, but actually this is why we are calling it, it's actually this NR unlicensed, a 5G Multifier. And that has been going on. I mean, right now, as we know, it's an industry group. It continues its work. I mean, it's done a first specification release, and it continues evolving. And now 3GPP is endorsing placing NR in unlicensed bands at the concept level. We started actually roughly a year ago, maybe a bit longer, and now we just got the work started in 3GPP or approved, and to get started right after the summer. So this probably gives you an idea of where it took us to get where we are. This is not an overnight effort, basically something that you get up and you get done in the same day. Now, we talk about multiple types of spectrum, and this is actually a nice pictorial illustration of actually what we have today. So on the left, we have licensed spectrum. This is actually the best spectrum to have if you have it, right? I mean, it's very expensive, it's very scarce. I mean, you don't have much of it. I mean, there are government agencies that basically regulate and actually basically dosify it to the industry, and actually bands are identified over time, and every new G, 2G, 3G, 4G, new type of spectrum is basically identified and basically put up for auction. The nice thing about it is that it gives complete exclusive rights of access to the operating entity that acquire those rights, right? And in that sense, it's probably the best that one could expect from that point of view for that particular operating entity. On the opposite extreme, we have unlicensed spectrum. Just think about Wi-Fi. Those are bands pretty much everywhere. There are some sub 1 gigahertz bands, 2.45 gigahertz. These are the Wi-Fi bands. 60 gigahertz bands are these Wi-Fi 11AB bands, and those are bands where effectively it's a little bit as we know, or as you should know, Qualcomm is also very big on Wi-Fi, and actually. We've been working actually on Wi-Fi for many years, but what I'm going to say is Wi-Fi is a little bit the jungle. So there is no arbitration whatsoever or basically governing access. So what ends up happening is actually the utilization of the medium is far from optimal. So it's made very easy. I mean, that's a given. But the utilization, particularly when you push to very high loads, is very inefficient. And actually, this is where, for example, LAA getting into unlicensed was trying to improve. And we'll try to talk more about it. But just going back to the types of the spectrum, shared spectrum is something in between. This is where a spectrum, so on a licensed spectrum, as long as you are confined to particular regulatory rules, I mean, a particular power constraint or time of use, basically periodicity of actually how this duty cycle transmission rules, basically you can access it in any way. Sharing actually now would try to put something in between licensed and unlicensed. What if now we know that what the entities that will be sharing or the type of systems that will be sharing the access are somewhat limited, or they know each other much better? In other words, do I have a very low duty cycle incumbent, for example, which I could try to basically just avoid, and then whenever it's not there, I can start raising the bar on actually these access rules, because, for example, it's very difficult to modify access rules when there is already an incumbent that uses a particular set of rules. And this is what happened with LAA and Wi-Fi, right? Wi-Fi was setting the tone for the access rules, and for LAA to try to outsmart Wi-Fi is just impossible, because then people would start thinking or perceiving it as unfair. It's trying to outsmart it, and then what ends up happening is everybody has to use the Wi-Fi rules. So this is where shared spectrum allows for actually new spectrum sharing paradigms. Now, when we talk about types of sharing, now we are within a spectrum sharing. We can actually look into vertical, horizontal, or combined sharing. What vertical sharing means is there is a priority involved. So there is a high priority incumbent, call it, that actually gets the right to access if he wills to do so. So that actually high priority incumbent will go, and actually potentially will not even be aware that there is an opportunistic secondary or lower priority device that basically tries to get its leftovers. Actually, in principle, this might not be attractive, but it is very attractive if that high priority access is a low duty cycle. So basically, if you have type of communications that do not require using the medium like more than half of the time, actually many times it's less than 10% of the time, you have 90% of the remaining resources fully available for others to use. And this is where vertical sharing would be, respecting a priority, and there is an incumbent that will have to be protected, and actually only the leftovers would have to be accessible, or would be accessible. Now, moving to a horizontal sharing, this is kind of the Wi-Fi way of sharing. Is actually everybody is the same, no priorities. There could be a QoS type of priority just for governing the rules of these basically backup windows for the contention after contention. But at the high level, from the purely Mac design, accessing the medium, it's everybody's equal. And actually, we are trying to share the medium. So if I do detect, if I'm actually a communication device, and I try to detect, I try to use the medium, I'm going to try to detect whether it's available. If it's not available, I'm going to use it. If it's available, if it's being used, I'm not going to be basically accessing it. So basically, there is the notion of listen before talk. Basically, just trying to check, avoid effectively communication devices speaking over each other. And then combined sharing is basically putting the two together. I mean, as you can, we will see in a moment. So moving on to slide 10, now we have an illustration of actually two particular examples that actually will meet into a final, basically a combined example. So in the top left, you have this incumbent that I was mentioning. This is a system that actually requires the use of the spectrum, its own spectrum, for some time, and actually is not all the time, and actually is there, right? It knows it's there whenever I need it, I use it. I could actually devise another communication entity that actually would try to opportunistically access the system without really affecting this incumbent. So the purple line or the purple boxes are unaffected on the second dynamic vertical sharing. But now I have these blue or dark blue boxes that actually in frequency and in time are giving opportunities for a second operator, basically with less priority, to get those resources. So the more you fill up the blank, the white space here of actually resources means capacity. The more boxes you have, the more bits you are moving, the better utilization of your spectrum is. And if you wish now into a traditional operator environment, I mean, call it Verizon, AT&T, or Sprint, T-Mobile, they paid for one channel. So that's the dark blue channel or the green channel. And this is theirs. Nobody else gets in. But actually, the utilization of their own channels might be far from full. So today we do nothing about it. And actually, imagine for a second that instead of just giving one channel to each of those two operators, I give the two channels to the two of them, and then I tell them go share. So actually, what you end up having is the next picture, where actually both operators, when needed, they would get access to both channels, and actually when not needed, basically they would just release. So you can just see, in principle, just because of this, you could allow, it would never be worse than you are giving half and half, because if it's really full utilization in frequency domain of the first one, you will have an entire one single blue box and one single green box for each of the two channels. And in time, what I would have is half of the time it will be blue, half of the other time will be green. The net effect is exactly the same, is the same capacity. But if you start having blanks, that gives opportunities to the other operator to go grab them, actually, without affecting the first one. And actually, this is what we're trying to do with all these NRN license and sharing. Basically, at a very high level, this is at the concept level, but this is what we're trying to do. Now you can put together the incumbent with the multiple operators into the next figure, where still the incumbent is there, and now I'm sharing horizontally between blue and green. So purple remains, and then blue and green share between each other. So 5G NR was designed to take advantage of new sharing paradigms. Actually, in the history of wireless, there are many, many examples that one can actually go back to and realize, oh, we did not do this in the perfect way. So for example, LTE TDD. Of course, LTE TDD is a very successful system, but actually, with all, I mean, in all fairness, LTE TDD was an after fact of LTE FDD. So first we designed LTE FDD, and basically we adapted to TDD. From day one, 5G is a TDD system, and the entire unlicensed sharing spectrum frequencies are TDD based. So it's a system that is defined for TDD. Wi-Fi, for example, was defined for TDD from day one. There are a lot of learning lessons that we've acquired over the years. LTU, LAA, LTE Wi-Fi aggregation, multi-fire, CBRS, the 3.5 gigahertz band in the US, plus LSA and the 2.x bands in Europe, actually allowing for sharing. If you put those together with actually, number one, a new NR radio physical layer, which is much faster with actually native widebands, very low latency, a scalable numerology, encompassing range, I mean, basically frequency ranges from sub-6 to millimeter wave, opportunities in line with this or tying up to this low latency self-contained subframes, in the sense that transactions get completed within a subframe time duration. And also looking into opportunities to basically make the system forward compatible. By the way, this is something Qualcomm did try 9 years ago for LTE, and unfortunately we did not get it through for release 8 LTE. This is actually defining the opportunity to basically designate resources that have to be ignored by a certain population of terminals. So those resources are to be ignored, because actually in the future, I might just try to put something different, right? And you don't want to confuse those devices that will not understand. But actually that is an integral part today of 5G, this forward compatibility. So as I said, we are talking about a standalone as well as license assisted. We're talking about a multiple connectivity from NR, LTE, and Wi-Fi. And as I said, NR a standalone unlicensed. I mean, basically being considered as a forward compatible aspect as part of the study item of NR from day one. Now, this is a picture that you have actually, maybe you have looked at multiple times. I'm not going to spend too much time on it, but effectively it just shows how you can scale numerology basically within a particular band, how you can actually multiplex high priority traffic, this ultra reliable low latency traffic, and actually how can you make transactions self-contained. And then all these mixed with a possibility to have blank subframes, which as I said is, it's actually an exit clause for actually having something in the future that right now we cannot really predict. So it's not going to affect legacy, because legacy will ignore it, but down the road you can do anything you want. So the subcarrier actually, or this scalability, is actually what is shown here is frequencies, subcarrier spacings. As you can see, this is the tone separation within an OFDM waveform. The top one is the one corresponding to LTE, which is 6 to 15 kilohertz. Well, it turns out that NR is actually expanding these to multiple use cases and actually scales with powers of 2, multiplying to these 15 to larger subcarrier spacing, 30, 60, 120, 240 kilohertz. And you can see by having larger subcarrier spacings, not shown here, you will have shorter symbol durations, which is very good for actually latency, and also for even complexity, because you would cover more bandwidth with less complexity, less FFTs. So this is also just in line or tying into the opportunity to have multiple use cases addressed by NR. Now there are 2 slides which actually I'll spend just a little bit of time. This is related to dynamic TDD and related to self-contained subframes. So if you look at it, maybe this slide 15, it's easier to see at first. Every subframe starts and ends with control. This is actually what to us means self-contained. or the first definition of self-containable. So you start a subframe with downlink control, there will be a data section, and there will be uplink control. In the data section, you could have downlink data or uplink data. And this, just to give you, this is not the way it works in LTE. In LTE, an entire subframe is downlink or an entire subframe is uplink. I mean, there is really no switches in between. What this allows is actually control, which is the single most reliable part of the system, is actually always going to be predictable, colliding with its own type of control. Downlink with downlink, uplink with uplink. And then what happens in the data could depend opportunistically on the scenario. And in the figure on the right, you can see that at the same time that a downlink, a cell is serving a downlink user, opportunistically an uplink, another UE nearby on a neighboring cell, which in traditional systems would also be served with downlink, so that actually you don't have this downlink uplink interference. It is now allowed to transmit uplink if it really knows or detects that its transmission will not affect the reception of the first UE. Actually, in this particular use case, I mean, you would need the downlink transmission to be empty, because if the first terminal is being served, the transmission of the second one will actually interfere. But you could always move this second UE to the right, and that transmission could actually end up happening all the time. Whenever the downlink transmission happens on the first cell, the second UE could do actually uplink transmissions without affecting the first communication. So this is actually is an integral part of actually NR. And now you can actually generalize it a little bit and precede the downlink control that we were referring to before with some headers. And headers, I mean, these are, it could be a blank space of time where I'm just trying to determine whether the channel has been reserved. So for example, to do this clear channel assessment a la Wi-Fi, a la LAA, or actually try to do headers for D2D or mesh communications or relays of any sort. So those that particular frame structure is supported in NR. So basically the opportunity of actually just starting with a building block and extending it with a header that I'm going to use for my own purpose, being NR license access or mesh communications. Now, if we ask ourselves, what is it that we bring new to the table when we look into NR sharing, spectrum sharing? Well, historically, sharing is not new, but actually most of the time it's associated with a database. So databases, I mean, so far has been a very slow, very slow adaptation of those. And actually many times goes by geography. And geography could just be, actually geography is difficult to just basically just say, you are coastal, you cannot share, right? Because actually I might just be in an underground, and actually I don't affect and I don't detect, or I can be in a hangar, anybody's communication. So it is actually important to actually go beyond this database and either make it dynamic or actually have OTA-based mechanisms to realize that actually sharing can take place. So this is actually enabling enhanced horizontal sharing. We also, whenever we talk about sharing, we portray it as basically this, basically go take all the channels at once and then use them all or let them for somebody else, right? But you can actually try to dissect in another dimension, especially in particular for the high bands, millimeter wave, which are basically transmissions that decay because of the propagation conditions of those frequencies very quickly. So then millimeter wave, for example, is a very prone to having these sharing type of techniques, special techniques for sharing incorporated. As I said, 5G NR has been designed with sharing in mind from the very beginning. And then there are different levels of actually, we'll talk about it in a second. What is actually what brings the main differentiator of licensed spectrum, in my opinion, is the opportunity to provide a QoS guarantee. So it's a quality of service guarantee. You know, if you need the channel is there. There are ways that actually one could actually try to bring those into sharing, and we'll discuss those in a second. But those actually, even actually different degrees of coordination could be enabled. And hopefully with this next a couple of slides, you will understand what I'm meaning. So there are two main, actually, if you wish, techniques or actually means to get sharing implemented. One is a fully uncoordinated. Basically, this is by local sensing of actually utilization of the medium, trying to enhance it in the best possible way. And the other one is, and this is what we're going to be calling uncoordinated sharing. And the other one is, imagine that I try to do better than that, and just instead of just having this jungle that I was talking about, where everybody is trying to sense everybody else, and then just access the channel. And when I access the channel, it's only mine and nobody else's. I'm going to try to be a little bit more organized. I'm going to regiment in some way the access. And I try to basically try to do as much as I would do in license, effectively, right? So I'm going to dissect the basic resources or slice resources. By default, half of them in time are for one operator, the other half are for the other operator. And basically, I'm going to allow opportunistic access of resources that are not being used by the high priority operator. And so now getting into a little bit more details on this uncoordinated, there are multiple dimensions where uncoordinated actually is important. One of them is this sensing and actually collision. Ways to avoid this sensing and collision, or to improve this sensing and collision. One is enable transmissions with much higher granularity for access, for actually starting and ending. This is where FELAA is going in its own way, but NR basically enables much shorter transmission intervals, and actually we're improving that in that matter. And the other one is actually sensing the environment for potential collisions. And there is such thing as, for example, if I'm two operators, I might be okay to collide with my own peer device. Effectively, cellular networks are designed for that. I mean, it's not like it's one at a time. It's not TDMing. I mean, so I might actually be okay with, I only need to yield to the other operator, but if I get access, if I see that it's from my same operator, I also tag along and basically continue accessing myself. So these are rules that actually would need to be brought back to regulatory bodies and actually to enhance. But it's just one particular example to improve this uncoordinated access. Another one is targeting particular type of devices for this silencing of actually medium access. And it could be just power dependent, for example. But maybe the coordinated is the one that actually brings about more opportunities when it comes to innovation. And actually, as we said, QoS is the main use case, or the main actually metric that we want to improve, so that actually we close the gap between unlicensed, pure unlicensed, and licensed. And as you can see, this 50-50 split that we have of resources can actually be provided by this default allocation. There is an opportunistic accessing of resources that is allowed when the resources of the high priority operator they are deemed to be empty or vacant. So actually that would enable closing the gap that we showed you before, the blank gap of actually unutilized resources. And then actually I could choose to have some resources that are just exclusive for one particular operator, call it sync signals, call it random access signals, very high priority tag communication signals, that actually I'm even putting them aside. I'm not even making them shareable, but it's just a very small, maybe 1%, 2%, 5% of the resources. Everything else, the 95% remaining, is up for sharing. Dynamic reuse also means I can actually, even though the medium is deemed to be used, I can, similar to the dynamic TDD, a particular device can detect that its own transmission will not affect the first one, high priority one, and indeed it will allow to basically go and use the resources for it. And if you now put this coordination together, what we can actually start thinking is this most advanced techniques that actually in the LTE days came about for transmission, and this is COMP. COMP stands for coordinated multipoint, and this is when you look into a cellular network, multiple cells will basically jointly transmit to a particular user. So it's actually the futuristic version of microdiversity of 3G days, if you wish. But actually now taking full advantage of actually all the MIMO advances and creating basically this high-dimensional MIMO system with many more antennas, the aggregated number of actually all the antennas of all the cooperating towers or cell sites, and actually enabling performance gains actually that are very, very attractive, and we will see that in a second. So this is actually the figure that will compare the performance of the different types of systems. We are going to basically in the x-axis look into different levels of load. Just think about to the left is less load, so less a lot of blanks. To the left is very load. Basically, the resources are utilized to the maximum extent. Then actually on the vertical axis, just think about is a relative gain in user perceived throughput. So this is what the user will perceive its own throughput to be. So if we start with static resources in the far top right, you will see the two operators, half of the time for one operator, the other half for the other operator. You get this type of curve. I mean, basically it's flat. I mean, it doesn't really go under a particular level, which is good. It's a guaranteed access. But actually, I can do better if I do uncoordinated sharing. That is effectively, in general, I'm going to get a 2x in the low load because I'm going to get in the limit, the load that actually the first operator is not using for myself. And then in the other limit, I'm going to basically do 50-50, which is what I did for frequency static allocation. So now we look back into non-sharing, but comp, because comp is basically this multi-dimensional MIMO scheme where now all the cells from a given operator will actually cooperate into the transmission. So this is still a static allocation, one channel for one operator, another channel for the other operator, but now each of those operators perform comp. You see the gains are actually very attractive. But now if I put comp together with this sharing, the gains do not basically vanish. Actually, indeed, they get they are still there, and actually is not anymore that we have a crossover point or a meeting point towards the extreme load. It's actually a gain that sustains over the entire regime of loads. And in that sense, what we do is one operator will realize resources are available, and whenever they are available, it will use comp. And actually, each operator will use, whenever it's accessing the system, it will use comp. So basically, all the cells will cooperate. But whenever there are empty pockets of actual resources, the secondary operator will actually try to grab them using comp. There is an upper bound, if you wish, a curve, which is actually, I would say it would be even trying to be a little bit more aggressive when it comes to scheduling. And it is actually when it comes to treating devices from different operators as even your own. And again, this is playing with nulling and actually these MIMO techniques that we've been talking about, and actually enabling a joint transmission, not even temporal, still a split of the two operators using comp each one, but actually a concurrent transmission of especially multiplexing multi-operator transmission. So just try to wrapping up in the next couple of minutes. We are, as you are seeing, we're taking spectrum sharing to the next level in 5G. We are trying to drive 5G standardization. We are actually trying to, we are very actively working on prototyping where technology development is taking place this year. We are expecting to have industry field trials coming up, hopefully starting next year. And what we see is this is enabling enhanced mobile broadband speeds. It's actually also extending 5G ecosystems to new use cases. We talk about this, I mean, this is we'll cover all the types of bands, licensed, sharing, and unlicensed, and from below 1 gigahertz to millimeter wave. And spectrum sharing is valuable for a wide range of deployments. So first, it will allow for more spectrum to aggregate. It also will enable these other type of applications, we call them enhanced local broadband, for example, for neutral host and neighborhood network. These are venue specific, for example, capacity, high capacity areas. And then there are other types of actually applications are private IoT networks, enterprise IoT, industrial IoT, which are new from the point of view of actually today's main use cases of actually cellular technologies. Just to conclude, 3GPP is starting in our licensed spectrum. This is the new logo of 5G, recently approved. We are very excited with spectrum sharing. We do believe it does bring about new opportunities for innovation, and we do see it valuable to a wide range of deployment types. As mentioned by Sean at the very beginning, the scope of the initial scope of this webinar was changed. And I invite you all to May 31st, private IoT networks, presented by my colleague Nabil Myers, on this topic, deserving actually a particular, webinar for its own. And I'd like to conclude here and open up for questions. Thank you very much.
Juan, thank you very much for that insightful presentation. We've got lots of great questions here, and we'll try to get to as many as possible. So with that, Juan, what is the outlook for spectrum sharing in millimeter wave bands?
Actually, that's a good question. As discussed earlier, millimeter wave comes with its own physical properties where actually the waveform decays pretty rapidly. So, for example, 11AD is one actual deployed system, and actually you can see from one group to the other, there is barely any actual interference. So in that sense, it does enable the use of these spatial sharing techniques in a big way. So we do believe it's actually very, very well suited for the discussion today, for the spectrum, for sharing a spectrum, and try to find the additional dimensions for slicing. I mean, spatial being one of them, which naturally comes with millimeter wave with these very narrow band pencil type pencil point beams that is actually being built upon.
Right, and then another one of our viewers would like you to weigh in on how, as the 5G standard evolved, is it going to be downlink biased like previous generations, or will there be more emphasis on the uplink this time?
That's a great question. Actually, I believe that the standard will be generic enough that will enable both types. And actually, I did not discuss, but the structure, the frame structure that we did discuss, in contrast to the TDD LTE frame structure, which had very rigid 7 configurations. And out of those 7 configurations, a network operator would just pick one and use for the entire network. I mean, pretty much worldwide network. Now, NR is defining a much more granular entry point or building block, which is this self-contained subframe. And we do see this possibility to geographically adjusting to the traffic needs. So for example, and in particular, it goes also very much into, ties in very well with the small cells. One thing is macro cells, and probably for macro cells, you would have to come up with a particular split, because otherwise macro to macro interference is very hard to handle. But once you put the small cells in the mix, those are small cells we would expect to be much more agile into adjusting to traffic types. So I think the standard will be very generic, but so far we are seeing a still downlink centric needs for the use cases that we are currently are basically getting interest about.
And we've got another great question here from one of our viewers who wants to know, how do these sharing models intersect with the 5G practice of network slicing? Can operators slice their own networks and share spectrum with others?
Actually, that's a good point, and it does. So now it's basically going one layer above, or a few layers above. I mean, spectrum sharing, as discussed in this presentation, basically encompass the lower layers, the access to the medium, the waveform, basically how agile basically things get moved in and out of the medium. Now, when you look into network slicing, it's a very good actually use or very good feature that 5G network is bringing about. And it does see, it does, as also discussed in the scope of the study item, there are opportunities for network operators to take a slice that actually could for example, serve the purpose of, for example, unlicensed service, and basically build the system around it. The slicing is also enabling, for example, for private IoT, just taking the components of the network that we really want or are interested on, and leaving aside others that maybe we're not really interested on. So effectively, it's a good building block to add upon what we just presented.
And Juan, another one of our viewers asks, are database type sharing approaches not going to be considered at all for 5G NR sharing use cases?
I would say it is difficult to, I mean, it's probably too strong to say it's not going to be considered at all. I mean, I would just say is the de facto, is the entry point. I mean, of course it could be done, but we want to do better. So I would imagine that there is, it will be basically supported, but actually there will be also opportunities to do better and actually enable these much more, instead of just a geography base where now a particular coastal region or a particular city or a particular neighborhood, if it's much more local and depending on the actual radio conditions of that particular device surroundings. And this is where we want to be, right? I mean, a little bit more pinpointing a particular device, a particular access need in a particular point in time and space. So I would imagine the database will be there, but we want to go beyond those for these new paradigms.
And Juan, relative to your discussion of comp, the question is, if coordinated sharing performance is better than uncoordinated, why not just do that?
That's actually a very good point. What I would say is the use of uncoordinated really comes because there is an incumbent. So, for example, as I also alluded to, if Wi-Fi is present in a particular band, it's very, very difficult to try to outsmart it without having Wi-Fi community, if you wish, ourselves, saying this is unfair to Wi-Fi. So effectively what happens is everybody has to use the same MAC, the same access rules in that sense. So for coordinated, you will need to have people respecting, for example, access slots to basically another operator, and Wi-Fi today doesn't do it. So why would I have, if now you have a device that actually is put in a surrounding of a Wi-Fi, it would be in disadvantage. But if you go to another spectrum where either you have a low duty cycle incumbent or it's a complete greenfield type deployment, then you can define the access rules from scratch. And those are the ones where coordinated access techniques shine the most.
And Juan, our final question, and I think a good opportunity to reiterate some of the key themes of this presentation, is from a viewer who asks, what's so exciting about this new study item? Is it not just a continuation of LAA?
Actually, it's a good point. Just let me clarify. LAA will have, it has actually its own evolution with a release 15 LTE study work item, and that is further enhanced LAA. I did mention briefly with somewhat limited scope, but something that neither, I mean, of the versions of LAA, release 13, release 14, now the release 15 encompass, was the use of unlicensed spectrum in a standalone fashion. And this is the first time ever that actually we'll be able to see a cellular technology running completely standalone on a licensed band.
Well, Juan, thank you again for the presentation today regarding 5G NR and unlicensed spectrum. And a reminder to our viewers that on May 31st, we will be hosting another webinar where we will get into private IoT networks, and Juan's colleague Neville Majors from Qualcomm will be presenting in that. And the slides and the video discussion from today's webinar will be made available in the near future. Thank you again for your participation.
Thank you all.